Hi, my name is Petersen, and my role in this project was to assist in the data analysis and coding processes and test the AEV on the Jurassic Park track.
Hi, my name is Windbigler, and my role in this project was to type the code and implement it onto the AEV.
Hi, my name is Marlee Friedman, and my role in this project was to assist in the design of the AEV and the coding process.
Hi, my name is Scarmuzzi, and my role in the project was to construct and design the AEV as well as analyze the data and graphs.
The mission of the AEV project is to design an advanced energy vehicle that travels throughout Jurassic Park. The vehicle travels from the starting gate to the visitor center and stops for 7 seconds in order to check for pedestrians. Then the vehicle travels to the storage facility to pick up baby dinosaurs. The vehicle will then travel back towards the visitor center and stop for another 7 seconds. Lastly, the vehicle will travel back to the starting point. Not only will the vehicle be able to travel the route to the specifications of the Jurassic Park team, but travel using the least amount of energy possible.
Sketch 1 focused on the balance and aerodynamics of the system. 2 propellers were stationed on the right and left wings, while the Arduino controller was mounted on the bottom of the device and the battery was mounted to the front. The device used an L-shaped arm to connect it to the AEV track.
Sketch 2 had a slightly different setup. The propellers were mounted much closer to each other in comparison to Sketch 1. The battery was located at the back of the vehicle, and the L-shaped mount was stationed near the front.
Sketch 3 included 2 motors attached to the rear of the device, followed by 2 propellers stationed fairly close to one another. The L-shaped arm was also toward the rear of the device.
In Sketch 4, the battery sat under the L-shaped arm and the propellers were mounted under the wings in the middle of the vehicle. The Arduino controller was mounted to the bottom of the framework.
Sketch 1 of the initial design phase was chosen as the best candidate for prototype design due to screening and scoring methods. However, propeller orientation and weight of the vehicle were taken into account and tested later.
The new design had a balance problem in which only the back wheel was on the track. This was fixed by moving all the parts in front of the wheels, which improved the center of balance. In the coding process, there is difficulty in determining which mark counts to use in order for the vehicle to reach the gate sensor. We had difficulties keeping the vehicle consistent. The inconsistency was due to scratches in the reflectance sensor tape.
Throughout the improvement process of the AEV, data and graphs were analyzed in order to further improve the vehicle. Various factors such as energy input for certain commands was analyzed. For example, the energy efficiency graphs would be examined for 2 runs using 2 different commands to complete the same task. The first run would use more power but with less time, and the second run would use less power with more time.
In order to create a more efficient vehicle, the team minimized the weight by taking off 2 wings and used a smaller base structure. Additionally, the AEV was made into a puller system where the propellers were moved to the bottom of the wings and in front of the body, because they were hitting the Arduino wires and slowing them down. The Arduino was moved back in order to add the magnetic connector. The battery was then moved under the wheels into a vertical position to create a better center of mass and increase balance.
Throughout this process, I learned a lot about how Arduino coding works. I learned how each command influences the actions of the vehicle, and it was interesting to me to see how increasing the power input can greatly affect the energy efficiency.
During this project, I learned the value of good communication and how teamwork can accomplish goals in a quick and efficient manner.
The brainstorming as well as the trial and error process is extremely influential in the creation of the final design and the working code.
I learned that there were many similarities between this project and a real-world design project. For example, auto testing of vehicles requires many models and test trials in order to obtain efficient results. And this concludes our AEV project. Thank you for watching.
We're gonna watch that again.